Download this code from codegive.com, link in the description below. O'Reilly Webcast Introduction to Gearman, a deep dive with code examples. This tutorial delves into Gearman, a powerful open-source job distribution system. We'll explore its core concepts, architecture, benefits, and provide practical code examples using Python to illustrate its usage. This is inspired by the classic O'Reilly webcasts that often covered practical solutions with hands-on demonstrations. What is Gearman? Gearman is a high-performance, language-agnostic system designed for distributing tasks to machines across a network. It allows you to parallelize processing, handle large volumes of work, and even distribute tasks across different programming languages. Think of it as a work queue management system on steroids, optimized for speed and scalability. Key benefits of Gearman **** parallel processing ** break down complex tasks into smaller, independent jobs that can be executed concurrently on multiple machines. This significantly reduces overall processing time. Language-agnostic * workers can be written in various languages, PHP, Python, Perl, Java, C, etc., and interact with the Gearman server seamlessly. This allows you to leverage the strengths of different languages for specific tasks. Load balancing * distributes jobs evenly across available workers, preventing bottlenecks and maximizing resource utilization. Fault tolerance * Gearman can be configured to retry failed tasks, ensuring that work is completed even if some workers encounter issues. Scalability * easily scale your processing capacity by adding more workers to the Gearman network. Asynchronous processing * offload time-consuming tasks from your application to be processed in the background, improving responsiveness for the user. Simplified architecture * Gearman handles the complexities of task distribution, allowing developers to focus on the logic of their applications and workers. Gearman architecture, the core components. Gearman's architecture consists of three primary components. 1. Gearman server, Gearman, the central hub of the Gearman system. It's responsible for receiving jobs from clients, distributing them to available workers, and managing job queues. It is the traffic controller of the system. 2. Client ** an application that creates and submits jobs to the Gearman server. The client knows what task needs to be executed, but it doesn't do the actual processing itself. It simply enqueues the task. 3. Worker ** an application that registers with the Gearman server and declares its ability to perform specific tasks. When a job is available for a task the worker has registered for, the Gearman server assigns the job to the worker. The worker executes the job and returns the result to the Gearman server, which then forwards it to the client. Workflow ** One client submits job ** a client application sends a job request to the Gearman server, specifying the function to be executed, example thumbnail_generator, the data to be processed, example an image file, and other parameters. 2. Server queues job ** the Gearman server receives the job request and adds it to its internal queue for the specified function. 3. Worker available ** a worker application, having previously registered its ability to perform the thumbnail_generator function, connects to the Gearman server and indicates its availability. 4. Server assigns job ** the Gearman server assigns the job to the available worker. 5. Worker executes job ** the worker receives the job data from the server, executes the assigned function, example generates a thumbnail, and returns the result to the server. 6. Server returns result ** the Gearman server receives the result from the worker and forwards it back to the client application that originally submitted the job. Setting up Gearman ** 1. Install Gearman server, Gearman. Linux, Debian/Ubuntu sudo apt-get update and sudo apt-get install Gearman job server. Linux, CentOS/rhel sudo yum install Gearman. Mac OS, using homebrew brew install Gearman. To install Gearman client libraries you'll need the Gearman client libraries for your chosen programming language. For Python, use the Gearman library. Code example, thumbnail generation using Gearman, Python. Let's create a simplified example of a thumbnail generation service using Gearman. We'll have a client submits image file paths to the Gearman server to generate thumbnails. A worker receives image file paths, generates thumbnails, and returns the thumbnail file path. A Gearman server manages the communication between the client and worker. 1. The worker, thumbnail_worker.py. Explanation import Gearman imports the Gearman library. Import OS imports the OS module for file system operations. From pil import image imports the image class from the pillow library. Install pillow using pip install pillow. This library is crucial for image manipulation. Gearman_server specifies the address and port of the Gearman server. The default Gearman port is 4730. *generate_thumbnail, job, this is the function that will be executed by the worker when a job is received. It takes a job object as input, which contains the data submitted by the client. *image_path equals job.data, extracts the image path from the job data, the data sent by the client. *image.open, image_path, opens the image file using pillow. *img.thumbnail, thumbnail_size, generates a thumbnail of the image. The thumbnail method modifies the image in place to fit within the specified dimensions. Saves the thumbnail to a new file with _thumb appended to the original file name. Returns the path to the generated thumbnail. gm_worker equals Gearman worker, Gearman_server, creates a Gearman worker instance, connecting to the specified Gearman server. It accepts a list of server addresses in case you have multiple Gearman servers for redundancy or load balancing. gm_worker.register_function, generate_thumbnail, generate_thumbnail, registers the generate_thumbnail function with the Gearman server, associating it with the name generate_thumbnail. This tells the server that this worker is capable of handling jobs for the generate_thumbnail function. The first argument is the name the client will use to call this function, and the second argument is the actual Python function to execute. gm_worker.work, starts the worker, making it listen for jobs from the Gearman server. This is a blocking call. The worker will continuously run until it's manually stopped, example by pressing Ctrl+C. 2. The client, thumbnail_client.py. Explanation import Gearman imports the Gearman library. Import time imports the time module for adding delays. Gearman_server specifies the address and port of the Gearman server. Image_paths a list of image paths that will be processed. Important you need to replace these with actual paths to image files on your system. The worker will fail if the files don't exist. gm_client equals Gearman client, Gearman_server, creates a Gearman client instance, connecting to the specified Gearman server. Submit_thumbnail_job, image_path, Asterisk this function encapsulates the logic for submitting a job to the Gearman server and handling the response. Asterisk job underscore request equals gm underscore client dot submit underscore job, generate underscore thumbnail, image underscore path dot encode, UTF-8, submits the job. Generate underscore thumbnail is the function name that the worker registered. Image underscore path dot encode, UTF-8, is the data to be processed, the image path, encoded as bytes. Gearman transfers data as bytes. The submit underscore job method returns a Gearman job request object, which allows you to track the status of the job. Asterisk thumbnail underscore path equals job underscore request dot result, waits for the job to complete and retrieves the result. This is a blocking call, the client will wait until the job is finished. The result method returns the data returned by the worker. Asterisk the code then checks if a thumbnail path was returned successfully and prints the result. Asterisk the try, except block handles potential Gearman errors and other exceptions. Asterisk the code iterates through the image underscore paths list and submits a thumbnail generation job for each image. Asterisk time.sleep, 1. A small delay is added between job submissions to prevent overwhelming the Gearman server in this simple example. In a real-world scenario, you might adjust this delay based on the workload. 3. Setting up the test images. Create 3 images called image1.jpg, image2.png, and image3.jpg and put them in the same directory as the Python scripts. These can be very simple images, for example, screenshots from your desktop. Running the example asterisk. 1. Start the Gearman server asterisk open a terminal and run gearman. You might need sudo gearman depending on your system. Leave this terminal window open. The gearman process must be running for the client and worker to communicate. 2. Start the worker asterisk open another terminal and navigate to the directory where you saved thumbnail underscore worker.py. Run python thumbnail underscore worker.py. The worker will connect to the Gearman server and start listening for jobs. Leave this terminal window open. 3. Run the client asterisk open a third terminal, navigate to the directory where you saved thumbnail underscore client.py, and run python thumbnail underscore client.py. The client will submit thumbnail generation jobs for the images in the image underscore paths list. Expected output asterisk. Asterisk worker terminal asterisk you should see output indicating that the worker received the image paths, generated the thumbnails, and saved them. Asterisk client terminal asterisk you should see output indicating that the client submitted the jobs and received the thumbnail paths. Important considerations and enhancements asterisk. Asterisk error handling asterisk the error handling in the example is basic. In a production environment, you should implement more robust error handling to catch and log errors, potentially retry failed jobs, and provide informative error messages to the client. Asterisk data serialization asterisk Gearman transfers data as bytes. If you need to pass more complex data structures, example dictionaries, lists, you'll need to serialize them to a byte string, example using JSON or pickle, before submitting the job and deserialize them on the worker side. The example above used a string, the file path, which could be directly encoded to bytes. Asterisk background jobs asterisk the example submits jobs that the client waits for the completion of. Gearman also supports background jobs, where the client submits the job and doesn't wait for the result. This is useful for tasks that don't require immediate feedback. To submit a background job, use gm underscore client dot submit underscore job underscore background, instead of gm underscore client dot submit underscore job. Asterisk job priority asterisk Gearman allows you to assign priorities to jobs, high, normal, low. This can be useful for ensuring that important jobs are processed before less important ones. Use the priority parameter of submit_job to specify the job priority. Example gm_client.submit_job, generate_thumbnail, image_path.encode, UTF-8, priority equals high. *timeouts*. You can set timeouts for jobs. If a worker doesn't complete a job within the specified timeout, the job will be marked as failed and can be retried or handled differently. *configuration. Gearman has various configuration options for tuning performance and behavior. Consult the Gearman documentation for details. *security. For production deployments, consider using TLS, transport layer security, to encrypt the communication between the Gearman server, clients, and workers. *scaling. For large-scale applications, you can deploy multiple Gearman servers in a cluster to handle a higher volume of jobs. Real-world use cases. *image/video processing. Generating thumbnails, encoding videos, applying image filters. *text processing. Indexing documents, performing sentiment analysis, translating text. *data analytics. Processing large data sets, generating reports. *web crawling. Crawling websites and extracting data in parallel. *machine learning. Training machine learning models on distributed clusters. *batch processing. Handling large batches of data processing tasks. Conclusion. Gearman is a valuable tool for building scalable and efficient distributed systems. By offloading tasks to background workers, you can significantly improve the performance and responsiveness of your applications. This tutorial provided a comprehensive introduction to Gearman, covering its core concepts, architecture, and practical code examples. Remember to explore the Gearman documentation and experiment with different configurations to optimize its performance for your specific use case. This setup mirrors what you would expect to see in an educational or reilly webcast, bridging the gap between theory and practical, runnable code. Remember to replace the placeholder images with real ones for the example to function correctly.